Imagine drifting so far from Earth that the sun no longer feels like a star. It feels like a memory, no blue sky, no warmth on your skin, no sunrise, just darkness so complete that your brain begins to misfire trying to understand it. And in that darkness, your instincts tell you something simple. This must be the coldest place imaginable. Because what could possibly be colder than empty space? But that assumption is wrong. Not slightly wrong, completely wrong. Because somewhere in our galaxy, thousands of light years away, there exists a place so cold that even space itself is too warm for it. A place so unnatural that, if you described it in a science fiction script, most people would assume you were exaggerating. A place created not by silence, not by stillness, not by some frozen dead world locked in eternal night, but by violence, by collapse, by a star tearing itself apart. And that is what makes this story so unsettling. The coldest known natural place in the universe is not calm. It is not peaceful. It is not dead. It is the aftermath of something going catastrophically wrong. This is the story of the Boomerang Nebula, and the deeper you go into it, the less it feels like astronomy, and the more it feels like the universe revealing one of its strangest secrets. Most people think of cold as the absence of heat. A winter night, a frozen lake, a block of ice left too long in darkness. But the universe does not play by human intuition, because even the emptiest regions of space are not truly empty, and they are not truly at zero. The cosmos still carries a faint thermal afterglow from the birth of everything, a relic from the Big Bang itself. That background temperature fills all of space like a ghostly residue of creation. It is everywhere, a universal baseline, a kind of faint warmth embedded into reality. So when astronomers realized that the Boomerang Nebula had dropped below that baseline, the discovery was not merely impressive. It was disturbing, because it meant nature had somehow produced a region colder than the leftover heat of the universe itself. Think about what that means. The oldest light in existence, the ancient glow from the beginning of time, still blankets the cosmos. And yet this one place managed to sink beneath it, as if a dying star found a way to create a pocket of anti-warmth. Not by breaking physics, but by obeying physics so ruthlessly that the result looks impossible. That is the first unsettling part of this story. The second is what the Boomerang Nebula actually is. It is not a planet, not a moon, not a black hole, not a giant frozen sphere floating in the dark. It is a preplanetary nebula, a brief and unstable phase in the death of a star, a transition state, a stellar body caught in the act of becoming something else. You are not looking at a finished object, you are looking at a process, a collapse in motion. A star shedding its outer layers into space in the violent moments before its final transformation. And that matters, because it means the coldest place we know of is not some permanent monument of cosmic frost. It is temporary, fragile, a brief accident of timing and motion, a short-lived wound in the fabric of stellar evolution. Now here is where the story gets stranger, because if I told you a dying star had created one of the coldest places in existence, your first reaction would probably be disbelief. Stars are heat, stars are radiation, stars are pressure, fusion, plasma, fire. The idea that a star's death could create a natural freezer colder than deep space sounds wrong at the level of instinct. But the universe has a brutal habit of producing extremes through opposites. And in this case, the secret is expansion. When gas expands rapidly, it cools. That sounds abstract, but you have seen smaller versions of it on Earth. A pressurized can releasing gas becomes cold to the touch. The escaping material spreads out, loses energy density, and its temperature drops. Now take that simple idea and scale it up to a cosmic catastrophe. Imagine an enormous volume of gas being blasted outward from a dying star at astonishing speed, faster and faster, far beyond what a normal stellar wind should be doing. The gas rushes into space, spreads out violently, and in doing so, cools to extraordinary levels. That is the leading explanation for the Boomerang Nebula's impossible cold. A hyper-fast outflow of material, expanding so aggressively that it has refrigerated itself below the natural background temperature of the universe. But that explanation only pushes the mystery back one step. Because now the real question becomes this: what could possibly drive that kind of outflow? Why is this dying star ejecting material with such extreme violence? And this is where the theories become fascinating. One theory points to a hidden companion star, a second object orbiting the original red giant. At some point, as the larger star swelled during its late life, That companion may have spiraled inward and plunged into the outer envelope, a stellar intrusion, a cosmic engulfment, almost like one star partially swallowing another. If that happened, the energy released could have blasted huge amounts of gas outward in an enormous asymmetric eruption. And suddenly, the Boomerang Nebula stops looking like a quiet dying star and starts looking like the scene of a collision. Not the clean explosion people imagine when they hear the word supernova. Something messier, more intimate, a system destabilizing from the inside. A companion object sinking into a giant star's outer layers, dumping orbital energy into the envelope, and effectively helping tear the star apart. That theory matters because it explains two things at once. First, why the outflow is so fast, and second, why the shape of the nebula is so strange, because early images made the object look almost elegant, like a cosmic bow tie, symmetrical, beautiful even. But deeper observations suggested the truth was more complicated. The visible shape was only part of the story. There are layers to this object, structures inside structures, dust obscuring some regions, cold gas extending farther than the eye first realizes. What seemed neat and graceful may actually be the outer mask of a much more chaotic event, and that is another recurring pattern in astronomy. The universe often hides violence behind beauty, a ringed planet that would kill you, a sparkling nebula built from radiation and death, a perfect spiral galaxy full of collisions, and here, a nebula that looks delicate from a distance, but may be the product of one star consuming or destabilizing another. There is also a deeper thermodynamic weirdness here that makes the Boomerang Nebula feel almost cursed, because deep space already seems cold to us. Human beings are adapted to a narrow range of temperatures on a thin membrane of atmosphere around one planet. Everything beyond that feels hostile. So when we hear colder than space, the phrase does not just sound scientific. It sounds emotionally wrong, like saying something is darker than black or emptier than vacuum. But that is exactly what the nebula represents. Not an absence of heat in the ordinary sense. A region that is cooled through expansion so aggressively that the normal background warmth of the cosmos is effectively too hot for it. This raises another interesting idea. Maybe the Boomerang Nebula is not unique because the universe rarely does this. Maybe it is unique because these conditions are so brief that we almost never catch them in time. Think about that. Perhaps there are other dying stars, other transition objects, other violent outflows capable of reaching similar temperatures, but the window during which they are cold enough, visible enough, and nearby enough to detect may be vanishingly small. In other words, the Boomerang Nebula might not be a once-in-all-time anomaly. It may be the one example we caught with our instruments while the cosmic door was briefly open. That possibility makes the discovery even stranger, because it suggests the galaxy may produce these moments more often than we think, but only as fleeting episodes in stellar death. The coldest places in the universe may not be ancient frozen relics. They may be fast, temporary, transitional wounds that appear and vanish as stars unravel. And if that is true, then the coldest natural environment we know of is not really an object at all. It is an event. Now let's go one level deeper, because there is something almost philosophical hidden inside this. Human beings associate cold with stillness, with silence, with inactivity. When something freezes, it stops, it locks in place, it becomes rigid and inert. But the Boomerang Nebula completely reverses that intuition. Here, extreme cold comes from motion, from speed, from expansion, from matter rushing outward so violently that it cools itself into one of the most extreme environments ever measured. That reversal is profoundly unsettling. It means that some of the most alien conditions in the universe are not created by the absence of action, but by too much of it, not by stillness, but by instability, not by death as a quiet end, but by death as a turbulent transformation. And once you see it that way, the Boomerang Nebula starts to feel less like an isolated curiosity and more like a message about how the universe really works. Reality does not care about our metaphors. Our emotional categories mean nothing to it. Cold can come from chaos. Beauty can come from destruction. A dying star can create something colder than the thermal echo of creation itself. That is not poetic exaggeration. That is what is so unsettling about it. It is true. There are also observational mysteries that make astronomers cautious, because when we say this is the coldest known natural place in the universe, we are talking about what we have been able to measure and infer. And measurement in astronomy is never as simple as sticking a thermometer into a cloud. Astronomers read spectra. They study how gas absorbs and emits radiation. They build temperature profiles from light and motion and chemistry. So one open question has always been how the nebula's temperature varies across different regions. Is the entire outflow uniformly ultra-cold? Probably not. Are some regions colder than others, depending on density, velocity, and exposure? Almost certainly. Could there be hidden structure inside it, where dust, clumping, and geometry affect what we are actually seeing? Absolutely. That uncertainty does not weaken the story, it makes it better. Because it means the Boomerang Nebula is not a solved mystery. It is a measured mystery. We know enough to be stunned, but not enough to feel comfortable. And then there is the possibility that its record may one day be challenged. The universe is huge, absurdly huge. What we have observed so far is a microscopic fraction of what exists. There may be other ultra-cold outflows, other strange dying stars, other environments where physics creates similarly impossible-seeming results, perhaps even colder. But until we find them, the Boomerang Nebula holds this eerie title. Not because it was designed to, not because it is some mythic ice world, but because a star died in exactly the wrong way, at exactly the right scale for nature to build a freezer out of catastrophe. Now imagine for a moment what it would mean to actually pass through such a place. Not as a human body exposed directly, because you would never survive the broader conditions of space in the first place, but as a concept, as an observer moving through that expanding cloud. There would be no icy ground, no crystalline landscape, no frozen mountains. That is the trap in our imagination. We keep trying to turn astrophysical phenomena into weather. But this is not weather. It is an ultra-cold flow of gas and dust surrounding a dying star, diffuse, enormous, ghostly. The sort of environment where ordinary human intuition completely fails. And that may be the most science fiction part of all. Not that it is cold, not that it is strange, but that it refuses to resemble the things we use to understand coldness. It is not a blizzard, not an ice desert, not a frozen ocean. It is something far more alien than that. A near absolute zero stellar outflow created by violent expansion inside a collapsing system. Science fiction often imagines the strange by modifying the familiar. An ice planet, a crystal moon, a frozen starship graveyard. But the real universe does something more disturbing. It creates conditions that do not even bother to be visually intuitive. The coldest place is not a frozen object. It is a thermodynamic consequence of a dying star's instability. That is stranger than fiction, precisely because it does not care whether we can picture it. And then comes the final layer of this story. The Boomerang Nebula is temporary. It is already changing, already evolving, already moving on from the exact state that made it famous. The coldest known natural place in the universe is not permanent. It is a brief phase in a longer stellar death sequence. A moment, a snapshot, a cosmic condition that may only last a blink compared to the life of stars. That means we are lucky to be here at all to notice it. Think about the timing. Human civilization exists for a few thousand years. Modern astronomy for a tiny sliver of that. And within this narrow window, around an ordinary star in one galaxy among hundreds of billions, we happen to develop instruments capable of finding a dying object that entered a bizarre ultra-cold phase at just the right time for us to see it. That is almost eerie in itself. The universe contains these unbelievable states, and most of them come and go without witnesses. No audience, no record, no memory, just physics unfolding in silence. And for once, one of them happened while something on a small rocky planet had finally learned how to look up and understand what it was seeing. So what is the coldest place in the universe? Not a lifeless ice world at the edge of reality. Not a shadowed crater where sunlight never reaches. Not the empty black between galaxies. It is a shattered stellar envelope. A ghostly expanding outflow around a dying star. A place where thermodynamics, velocity, and instability combine to create temperatures lower than the background heat of the cosmos itself. A place born from violence rather than stillness. A place temporary rather than eternal. A place beautiful from a distance and deeply unsettling up close. And maybe that is the real reason this object lingers in the mind. Because it reminds us that the universe is not just bigger than we expect. It is less intuitive than we expect, more creative, more brutal, and far stranger than our instincts are prepared for. We look into space and think we are searching for distant versions of familiar things. Mountains, storms, oceans, ice, fire. But every once in a while, the universe reveals something like the Boomerang Nebula and reminds us that reality is under no obligation to resemble our imagination. Sometimes the coldest place is not frozen ground. It is a dying star screaming matter into darkness. Sometimes the strangest thing in the cosmos is not what breaks the laws of physics. It is what follows them to their most extreme conclusion, and that may be the most unsettling thought of all. Because if this is what the universe can do with one dying star, what other impossible seeming places are still out there, waiting for us to discover them?